Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This is this video channel with practice problems, smarturl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. You are given that the joint PDF of random variables x and y is f sub x of x f sub xy of xy equal to x plus y for x between 0 and 1 and y between 0 and 1, and 0 otherwise. Find the variance of x minus y. And here's a solution. The marginal density of x is the integral over all values of y from 0 to 1 of x plus y dy. That's xy plus 1/2 y squared from y equals 0 to y equal 1, so it's x plus 1/2 for x between 0 and 1 and 0 otherwise. And because of perfect symmetry between x and y in the in this probability distribution and in the PDF formula we were given, a PDF of y is the same, the marginal PDF of y. And then expected value of x is the integral from 0 to 1 of x times x plus 1/2 dx. And that's equal to 1/3 x cubed plus 1/4 x squared evaluated from x equals 0 to x equal to 1. So it's 1/3 plus 1/4, 4/12 plus 3/12, so 7/12. And the expected value of y is the same because of the symmetry we talked about. The expected value of x squared is the integral from 0 to 1 of x squared times x plus 1/2 dx. That's 1/4 x to the 4th plus 1/6 x cubed evaluated from x equals 0 to x equal to 1. That's 1/4 plus 1/6, and that's equal to 3/12 plus 2/12, or 5/12. And the expected value of y squared is the same, 5/12, because of the symmetry we talked about. And the expected value of xy is the integral from 0 to 1 of the integral of 0 to 1 of x plus y times the joint density x plus y dx dy. We calculate the integral first with respect to x. Well, actually, we multiply it out first. So it's the integral from 0 to 1 of the integral of 0 to 1 of x squared y plus xy squared dx dy. And then we evaluate the integral with respect to x. We get 1/3 x cubed y plus 1/2 x squared y squared evaluated from x equals 0 to x equal to 1. And we take the integral of that from 0 to 1 with respect to y. And that's equal to the integral from 0 to 1 of 1/3 y plus 1/2 y squared. And that's 1/6 y squared plus 1/6 y cubed evaluated from, well, it should be from y equal to 0 to y equal to 1. I had a typo there, my apologies, because the integral is with respect to y, of course. So I corrected it. So it's 1/6 y squared plus 1/6 y cubed evaluated from y equal to 0 to y equal to 1. And of course at 0, this is 0, so all we have there is 1/6 plus 1/6, which is 1/3. And we are looking for the variance of x minus y. Well, that's equal to the variance of x plus variance of y minus 2 covariances of xy. And that's equal to, well, the variance of x, e of x squared minus the mean of x squared, variance of y, which is e of x y squared minus the mean of y squared, minus 2 covariances, which the covariance is e of xy minus e of x times e of y. And we calculated all these values, so we just plug them in. That's 5/12 minus 49 over 144. That's the square of the mean. Again, plus 5/12 minus 49 over 144. minus 2 times 1/3 minus 49 over 144. And then this is 60 over 144 minus 49 over 144. And again the same, 60 over 144 minus 49 over 144. Minus 2 times 48 over 144 minus 49 over 144. Okay, so 60 minus 49, that's 11. And another 11, that's 22. And then 2, because minus negative 2 will become 2. So that's altogether 24 over 144. And that's 1/6, which is answer E. Please remember this is copyrighted material. The problem itself was written by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on the test.